Welcome pre-calculus students to class today on Wednesday the 30th. Hope you guys are having a good week so far. And I know Matthew's heading up, and probably Caleb too, I think, to the NACA tournament. So hope the soccer team does well up there. And hope you guys are ready to learn some math today. I've had more of you coming over and getting some help lately, so I'm glad you guys are starting to feel comfortable doing that. And please don't hesitate to contact me when you need some help on your math. Here are some announcements. Number one, we will have a quiz this weekend, so please be ready for that quiz this weekend. Integrity sheets. I'm going to go over this every single video, so you cannot say I didn't tell you. When you come to my house on a test Monday, you are not allowed to leave until you turn it in. You have to stay here. I'm just kidding. You're not allowed to leave and go home and watch more videos and do more homework. It's too late. Okay? Now, a lot of you have been doing that, and that's okay. Nothing wrong with that until now. And the reason is just creating too much work for me, guys, okay? And remember, I'm not saying that you cannot get behind. You're welcome to get behind on your videos. If there's something your family's doing, or if you soccer players have a tournament somewhere, whatever, that's fine. But when you come into my house on test Monday, at that point in time, all the videos and all of the homework has to be done. If it's not, that's your business, but I will not let you do it later and get credit for it. You can do it later, but you will not get points for it. So when you come into my house on test Monday from now on, you will hand me your integrity sheet. And you must have that with you. I'll remind you of that every day. And if you lose the integrity sheet that I gave you, you can make up your own. Just put a Monday, Tuesday, Wednesday, Thursday, Friday, Monday, Tuesday, Wednesday, Thursday, Friday, and then write down the assignment that you did on the corresponding day. And you'll turn that into me, okay? So you will not be allowed to leave Monday and go home and do more homework. We're not going to do that anymore, okay? And then lastly, final grades will be sent to your parents when test number 5 is completely turned in. Okay, so you get test number 5 to me, I will grade it, and I will ship off to your parents via an email your 9 weeks grade or your first quarter grade. And 2 of you have already completed that, and I've already sent your grades to your parents, okay? All right, moving on. Yesterday, well, let me get that in a second. Yesterday, we looked at simple trig equations. Today, we are going to take trig equations, and that should be equations, to a whole new level. So, men, be ready to think. Be ready to use your brains. The video will be long, but you won't have any homework to work on today. Tomorrow, I will not teach anything new, but instead, I will just give you homework to practice what we already covered. Okay? Sounds pretty good. So a lot of notes today, no homework, no notes tomorrow, but homework. All right, let's go ahead and get started with our trig equations. We are going to do 11 of those today. 11. So if each one takes about 5 minutes, that's 55 minutes. If each one takes about 3 minutes, that's about 33 minutes. The video will be anywhere from 40 to 60 minutes, somewhere around in there. All right? And here we go. Go ahead and copy this first problem down. Now, I'm not going to give you steps to these because there's really not any steps that you need. You're going to have to look at each problem, and each problem will be done a little differently. Now, to me, 2 cosine x equals -1. To me, it's kind of common sense to divide both sides by 2. Because when you divide both sides by 2, please watch what happens. You get -1/2. I divided this side by 2, and I divided this side by 2. Now, the reason to me that's kind of common sense is if you'll notice, now the trig function cosine is all by itself. So now I'm simply looking for cosine of what angle will give me -1/2. And by now we should be pretty used to knowing that we're going to go ahead and pull up our table. So there's our table. And now we look and we say, okay, when I take the cosine of 60 degrees, I get 1/2. So 60 degrees is the angle that I'm going to be dealing with. Okay? Let's go ahead and slide this table out of the way. We no longer need it. Now, notice that I'm saying cosine of what angle gives me negative 1/2. So that's going to put me in quadrant 2 because cosine is negative in quadrant 2, and also quadrant 3 because cosine is negative there. So 60 and 60. So I rotate to here. I did not quite go all the way to 180. I stopped 60 degrees early. So that would be 120 degrees plus 360k. And of course, 120 degrees is 2 pi over 3 plus 2 pi k. So there's your answers in degrees and radians for quadrant 2. Now quadrant 3, I would start here. I would go 180 degrees plus 60 more because you always stop at the hypotenuse. Notice on the first arrow I drew here, I stopped at the hypotenuse right here, and I stopped here at the hypotenuse. So 180 plus 60 more would be 240 degrees, and we always add 360. Okay, and then 240 degrees would be the same thing as 4 pi over 3 plus 2 pi k. So there's two answers from quadrant 3. One is in degrees and one is in radians. Not too bad. So notice I had to divide both sides by 2. Now let's take a look at number 2. Again, it makes common sense to me when I have a sign here that I want to get sine all by itself. Do you see that? So I would divide, sorry about that, I would divide both sides by 4. Now the reason I would do that is to get rid of this 4 right here, so they cancel out. So now I'm left with sine squared x equals 1/4. Now hold it, I don't want sine squared, so I take the square root of sine squared. Now the reason I'm going to take the square root of sine squared is so that I'm left with just sine right here, okay? But you cannot take the square root of one side unless you take the square root of the other side. And you should have learned in Algebra 2 that whenever you take the square root of both sides, you have to put plus minus in front of your radical. Okay? So the square root of sine squared is sine, and the square root of 1/4, well, we know that. The square root of 1 is 1, and the square root of 4 is 2. So the square root of 1/4 is 1/2. Now hopefully you've copied all this down. I'm going to go ahead and take the liberty to erase this just to give me some room because I need a lot more room. So do you see now how I got sine all by itself? Look at that. I got sine all by itself, and now I'm looking for an angle. Sine of some angle will give me plus minus 1/2. Well, let's take a look at our table here, and let's see what we can come up with. It looks like the sine of 30 is 1/2. The sine of 30 is 1/2. So I'm going to go ahead and write 30 degrees up here. That's the angle we're going to be using. I'm going to get rid of this table real quick here. All right, and now here we go. But I've got a problem here. I not only want a positive 1/2, I also want a negative 1/2. Well, it looks like we're going to use, this is pretty cool. Looks like we're going to use all 4 quadrants. So we have to know where sine's positive, here and here. And we have to know where sine's negative, here and here. So we're going to use all 4 quadrants because we need positive and negative 1/2. So no big deal. We'll have a lot more answers, but I wouldn't say it's a lot harder work. Okay, there we go. Let's start with quadrant 1. My first answer would be 30 degrees plus 360k, or you could simply put pi over 6 plus 2 pi k. So there's 2 answers, degrees and radians, for quadrant 1. Now let's go to quadrant 2. We're going to start here, and we're going to rotate to here. We did not go all the way to 180. We stopped 30 degrees short. So that's going to be 150 degrees plus 360k. And of course 150, let's see, would be 5 pi over 6 plus 2 pi k. So there we go. There's 2 answers from quadrant 2, one in degrees and one in radians. Now we're going to go on to quadrant 3. So we start here and we go all the way to 180 plus we go to the hypotenuse. So 180 plus 30 more would be 210 degrees plus 360k. And of course, 210 degrees would be 7 pi over 6 plus 2 pi k. And so there we go. There's two answers, one answer in degrees and one in radians for quadrant 3. And now let's go into quadrant 4. We're going to start here, and we're going to go all the way around, and we're going to stop at the hypotenuse. And so we did not go quite to 360. We stopped 30 degrees short, so that would be 330 degrees plus 360 degrees k. And then, of course, radians, let's see, would be 1, and what do we got? 1, 6, 1, and 5, so it would be 11 pi over 6. 11 pi over 6 plus 2 pi k. All right, so there's two answers from quadrant 4, one in degrees and one in radians. Let me get a quick drink of water. So there we go. We started off with this problem right here. It was what? 2 sine squared x equals 1. No, it was 4. Sorry, 4. We divided both sides by 4, then took the square root of both sides, and then once we had sine all by itself, like we did right here, we then went ahead and solved. Okay, so not too hard. But now let's take this a step further. Oh, now it's getting a little interesting. Can I please show you something you've never seen before? Now remember, we're going to do a bunch of these today, and then I'll let you practice these tomorrow for your homework. Now, it's really not that big of a deal. We just have cosine x. We have to get all by itself. So, you know, first of all, we're going to end up, what's this over here, Mr. Earhart? Don't worry about that. We'll get that in a second. So the first thing I would do is I would bring the negative or the positive 1 over and make it a negative 1. Now, as soon as you do that, of course, this is gone. We have a negative 1 here, and you're going to be left with 1/2 cosine x equals 0.2108. Now, next, I would divide both sides by 1/2. So divide by 1/2, these cancel, and divide by 1/2. And that's where your calculator comes in. Just type in 0.2108 divided by 1/2, and you will be left with cosine x equals 0.4216. So there, I got cosine all by itself. Now I'm going to go ahead and I'm going to slide this down just a little bit real quick, and I want to erase all this work here so I have some room. All right, and so hopefully in your notes you have all that written down. So I came up with this right here. Now, what is this right here? Well, let me explain to you what this is. Sometimes they will say to you, instead of putting plus 360k, or instead of putting plus 2 pi k, let's go back a page and look. Like we did right here, plus 360k, plus 2 pi k, plus 360k, plus 2 pi k. And don't forget, the reason we're putting that is because it means we can go around and around and around and around as many times as we want, and so we put k times. But sometimes, instead of doing that, they actually say, look, we just want you to give us the answers between 0 and 360. Now, just so you know, we have yet to learn interval notation. We're going to learn that later. But this means including 0, and because it's a bracket. And this parentheses here means not including 360. So we're going from 0. It'd be like this. We're saying 0. There, how's that? That's probably something you understand a little better. It's like saying x runs from greater than or equal to 0, less than 360. So it does not equal 360. I want to know all of the answers that x could be from 0 to 360, not including 360 degrees. And so that's actually a big help. Now we don't have to put all those plus 360k and plus 2 pi k and all that. So here we go. Let's go ahead and solve this. Well, we want to know cosine of what angle would give me 0.4216. Well, if we pull our chart up, you're going to see nowhere do we have 0.4216 on here. So that's not going to be a help. So next we go to our calculators. And remember what to type whenever you're looking for an angle. It's second cosine, and up pops cosine -1. And then you would put 0.4216. Now, if you type that in correctly and you're in degrees like you're supposed to be, you will get out. And by the way, how do I know to be in degrees and not radians? Good question. we're always going to try to work with degrees to make it easier, but what should your final answer be in? Well, you look at your domain right here. Since it's in degrees, our final answer will be in degrees. The next problem we're going to do, or number 5, notice your domain is going to be in radians, so we want our final answer to be in radians. So here, we want our final answer to be in degrees because this is in degrees. So make sure your calculator is in degrees, and you're going to get something like 64.9 or 65 point. Anyways, when you round it, you will get 65 degrees. So that means the cosine of 65 will give you this. But notice it's a positive 0.4216. So I've got to include both quadrants that cosine's positive in. And cosine is positive here, 65 degrees, and cosine is positive down here, 65 degrees. So here's one answer, rotate up. There's one answer, 65 degrees. And now here's the other answer. I'll do it in red here. We start here, and we rotate all the way around, and we stop at the hypotenuse. So we stopped 65 degrees short of going all the way to 360. So the other answer then would be 295 degrees. You don't have to put plus 360k because they told you right here in the original problem, we just want the answers that go from 0 to 360. And these two answers go from 0 to 360. Okay? Now this next one is going to be really, really, really hard. So I want to warn you to really, really, really get your thinking caps on and be ready to pay attention. Okay? This is going to be a pretty tough one. So let's take a look at this. I want to get tangent 2x by itself. By the way, you don't divide both sides by 2. This is an angle that you're taking tangent of, and it sticks together, okay? But what I will divide both sides by is 3. So divide by 3, divide by 3. This is a really hard problem. Watch what happens here. So I'm left with tangent of 2x equals -1. Now I'm going to go ahead and pull up my chart here, and I'm going to see when tangent, let's see, here it is. Tangent of 45 gives me a 1. Tangent of 45 gives me a 1. Okay? So with that in mind, I'm going to go ahead and write my 45 degrees right here, and that's the angle I'm going to use. And now watch carefully. Notice I want a -1, so I'm going to go to where tangent is negative. You're probably thinking, Mr. Earhart, this is an easy problem. Well, just hold on. Okay, we're not done yet. So in the second quadrant, tangent's negative, and in the fourth quadrant, tangent is negative. So there we go. Now here's where it gets difficult. Watch this. I'm going to rotate from here to here. So you think one answer is 135, but it's not. It's not, it's not, it's not. Look, the whole angle is supposed to be 135 degrees. Yes, that's true. But you have 2x, and I want to know what x is. So what you have to do is you have to come over here, and you have to say 2x equals 135, and now divide both sides by 2, and x equals 67.5. Now watch this. Now I'm going to rotate around to here, and notice I stopped 45 degrees away from going all the way to 360. So that's going to be 315 degrees. Okay? So that means this whole angle right here has to be 315 degrees. But I don't want to know what the whole angle is. I just want to know what x is. So what I have to do is I have to say 2x equals 315 degrees. Now divide both sides by 2, and x equals 157.5. Well, Mr. Earhart, it wasn't that hard. Hold it, guys. Look at your domain. You want all of the what? Not angles, all of the x values that fall between 0 and 360. So we might have to go around a couple times because notice, look, guys, when you had 315 degrees, you divided it by 2. And you got 157 for x. When you had 135 degrees, you divided by 2 and you got 67.5. The x values, listen to me, the x values are what have to be between 0 and 360. So we might be able to keep going here. Let's see what happens, okay? For example, we knew this entire angle right here could be 135 degrees. We knew that. We found that right here. Watch. Well, remember, you can always add 360 degrees to an angle. So if 135 was one of them, I'm going to add 360 to that. And when I do that, I'm going to get 495. Now divide both sides by 2. So this whole angle right here could be 495. It could be, yeah, if you don't believe me, go ahead and take your calculator real quick and take the tangent of 495, and you'll get out -1. But I don't want to know what this whole angle is. I want to know what x is. So I have to take 2x and divide, or set it equal to 495, divide both sides by 2, and I will get 247.5. 247.5. Now we might have to keep going, students. Let's see. Notice that this whole angle could also be 315 degrees. Remember, I found that right here. Well, what if I went around one whole time, so I added 360 degrees? Well, 315 plus 360 would be, let's see, 360, 675 degrees. So this whole angle here could be 675. If you don't believe me, go ahead and take the tangent of 675 degrees. If you do it correctly, you will get out a -1. So this whole angle could be 675, but I don't want to know what the whole angle is. I want to know what x is. So I'm going to take 2x, and I'm going to set it equal to 675. Divide both sides by 2, and you will get 337.5. 337.5. Now look at all 4 of these answers. Notice all 4 of these answers, 1, 2, 3, 4, all of them fall between 0 and 360, and that's why we had to keep going. Now believe me, if we took 495 and added 360 again, divided by 2, we would get out an x value greater than 360. So this is as far as we need to go right here, okay? But I'm telling you, you've really got to think hard to see this. It's not easy. It's not easy, okay? All right, let's move on to number 5. Okay, now we're getting into some pretty weird things. Let's backpedal here, problems 1, 2, and 3. In number 1, we just had to divide both sides by 2 to get cosine by itself. In problem number 2, we had to divide by 4 and take the square root of both sides to get sine by itself. In number 3, we simply had to bring the 1 over and make it a -1, then divide both sides by 1/2 to get cosine by itself. Here we simply had to divide by 3 to get cosine or tangent by itself. But now, look at number 5. Go ahead and copy this in your notes. This is going to be a lot different because here, on number 5, we've got a cosine squared and a cosine. So I'm thinking we might have to factor. So 2 cosine squared x, bring the negative cosine over and make it a positive cosine x, bring the 1 over and make it a -1, equals 0. Do you see what I did? I brought the positive 1 over and made it a -1. I brought the negative cosine over and made it a positive cosine. So now I've written it kind of in standard form. Now you're seeing why we learned to factor trig functions earlier this semester, because now in order to solve this, I've got a cosine squared and a cosine. I'm going to have to factor. Let me get a quick drink of water here. So here we go. Now, I've told you how I like to factor. I like to get rid of the cosine, and I write 2x squared plus x minus 1. That's just me. I multiply the 2 times the -1. I write the number right there. So 2 times -1 would be -2. And I say to myself, what 2 numbers multiply together would give me -2? When added together, give me a +1, which is right in the middle here. Well, that's going to be a +2 and a -1. When you multiply these, you get a -2. When you add them, you get a +1. So you bring down your first term, 2x squared. And then you do not write your middle term, positive x. You do not write that. You put positive 2x. Sorry, guys, my pen is messing up. Positive 2x and -1x. And of course, I got these 2 numbers from this over here. And then we bring down our -1. Now, pull out what's common in the first 2 terms, 2x, and you're left with x plus 1. And then over here, pull out a -1. And if you pull out a -1, you're left with x plus 1. And so the factorization, you write your common parentheses once, and you're left over with 2x minus 1. So the factorization of this would be cosine x plus 1, and I got that from this parentheses right here. And then your next parentheses would be 2 cosine x minus 1, and I got that from that parentheses there. Now hopefully you can always go back and rewind the video and watch it and all of that. I'm going to erase that. And now look what you do. Remember, you take each group and you set each group equal to 0. So I take the first parenthesis, set it equal to 0. I take the second parenthesis and I set it equal to 0. And now I solve. So here I bring the 1 over and make it a -1. So I'm looking for cosine of an angle that would give me a -1. Over here I bring the 1 over and I make it a +1. So 2 cosine x equals 1. Now divide both sides by 2. And I'm saying cosine of what angle would give me a 1/2. Cosine of what angle would give me a 1/2. Now again, you do understand, I hope, I've got to create some space here. So I'm going to come in here and erase stuff that hopefully you've written down. If not, you can back the video up. There we go. And now let's go ahead and pull these up here. All right. All right, there we go. So let's review. I moved everything to one side. So I had 2 cosine squared x plus cosine x minus 1. Then I factored. After I factored, I set each group equal to 0. And now I'm going to solve. I put my table up. Okay, first of all, cosine. Oh, I don't get a -1. Do you see a -1 anywhere on the table? No. So we'll come back to that in a second. How about 1/2 right here? Cosine of 60 is 1/2. Cosine of 60 is 1/2. So I know I'm going to put 60 degrees right here, kind of off to the side, 60 degrees for this part right here. Now, here we go. So I want cosine of an angle that gives me a +1/2. So cosine is positive here, and cosine is positive here. So I'll put a 60 here and a 60 here. Rotate up, so one answer is going to be 60. And then go from here all the way to here. I stopped 60 degrees short of going 360, so my other answer would be 300. So there's 2 answers right here for this part of the equation. Now, -1 is not on our chart, so would you please watch carefully what I do? Please watch. Go ahead and take your calculators, just like back here in this problem right here. 0.4216 was not on our table, so we used the calculator. Same thing here. Let's go ahead and type in second cosine. So inverse cosine of -1. Hit enter, and you will get out 180 degrees. Now please listen to me. We've never done this before, I don't think. Whenever you get out an angle answer for a trig equation, sorry for yawning, and it falls right on like 100, you understand 180 degrees is this right here. 180 degrees is this. It falls right on the x-axis. Anytime that happens, students, you need to check the other axis angles. And what are the axis angles? 90 degrees, 180 degrees, and 270 degrees. Now, why would I not check 360 degrees? Because look at your boundary up here. Your boundary says including 0, and look at the parentheses. It means all the way up to 360 or 2 pi, but not quite counting 360. So we're going to check each one of these and see if they give us out a -1. Well, if you type in the cosine of 90 degrees, you will not get out -1. And if you type in the cosine of 270, you will not get out -1. Okay? So the only answer between 0 and 2 pi, in which when you take the cosine of it, you get -1, is 180 degrees. Now, we would almost be done, except notice our domain is in radians. And whenever your domain is in radians, you must write your final answer in radians. So 180, if you convert that over to radians, is pi. And 60 degrees, if you convert that over to radians, is pi over 3. And if you convert 300 degrees over to radians, it's going to be 1 2/3, it's going to be 5 pi over 3. Okay? So there's your answers. Pi over 3, and 5 pi over 3. And I told you it's going to get pretty tough, okay? So we're just about halfway done. Moving on to number 6 now, and we have a total of 11 problems to do, okay? So moving on to number 6. Okay, Now, once again, I have a sine squared and a sine. It's like in the last problem I had a cosine and a cosine. So we're probably going to factor again. And notice we already have one side equal to 0. So when I go to factor this, you always pull out what's common first. Here I have two sines. Here I have one sine. So I'm going to factor out a sine. And when I do, I'm left with sine x minus 1 equals 0. So there, I factored. That's pretty simple. And now go ahead and take each group and set each group equal to 0. So sine x is your first group, set it equal to 0. And your other group is sine x minus 1 equals 0. Okay? Now I'm trying to see something here real quick. I'm concerned. I want to make sure I didn't make a mistake on the last problem. No, I did not. Okay, very good. And so I took my first group, set it equal to 0, took my second group, set it equal to 0, and now of course here sine x minus 1 equals 0. I've got to bring the 1 over and make it a positive 1, so I have sine x equals 1. I'm going to cross that off. Okay? So there we go. I pulled out a sine, so I factored. Then I took each group and set each group equal to 0. Now let's see if any of these fall on my table. None of them do. There's no 0 for the sine here, and there's no 1 for the sine. So we're going to be able to use our calculators quite a bit on this. So if you take your calculator and take second sine or inverse sine of 0, you're going to see that you will get out 0 degrees. Okay, now listen to me, please, students. Listen to me. That's what we call an axis angle. In other words, it falls right on the axis. Whenever that happens, remember, we got to check 90, we got to check 180, and we got to check 270. Anytime that one of your answers is an axis angle, you've got to check that. In other words, it falls right on the x or y axis. Then what we have to do is we have to go ahead and check the other one. So if you type in the sine of 90, you will not get out 0. However, if you type in the sine of 180, that's right, you do get out 0, don't you? So another answer to this equation right here is 180 degrees. The sine of 0 is 0, and the sine of 180 is 0. If you try 270, you'll see it won't work. Now let's come back over here to this right here. Sine of x equals 1. So we're trying to think of an angle that when I take the sine of it, I get 1. Well, it's not on your table, so we hit inverse sine of 1 because you are looking for an angle, and if you do that correctly with your calculator, you will get 90 degrees. So we know that one answer is 90 degrees. Now that's what we call an axis angle. So we better check 0, 180, and 270. Well, if you take the sine of 0, you will not get 1. If you take the sine of 180, you will not get 1. And if you take the sine of 270, you will not get 1. So none of the other axes angles work. So your answers would be 0, 180, and 90. But hold it, look at your domain. Your domain is in radians, so that means your final answer has to be in radians. So 0 degrees is 0 radians. 180 degrees is pi radians, and 90 degrees is pi over 2 radians. So again, it's a factoring problem, and that's just how you would do that, okay? Let's move on now to number 7. Number 7. Now, as soon as you see number 7, you think to yourself, oh, factor, factor. So off to the side, you write 10x squared minus 12x minus 7, and you go 10 times negative 7 gives me a negative 70. What two numbers when multiplied together give me negative 70? When add together give me negative 12. Well, guess what? There are none. There's nothing, so you can't factor it. So here's what I want you to learn from this problem. Whenever you have a sine squared and then a sine, or a cosine squared then a cosine, or a tangent, or whatever, written in kind of like a quadratic form, if you can't factor it, guess what? You can use the quadratic formula. You can use the quadratic formula. So 10 would be your A, negative 12 would be your B, and C would be negative 7. So, using the quadratic formula, now watch how I do this. Take some good notes. Negative b plus minus the square root of b squared minus 4ac all over 2a. Now, if you made your substitutions correctly, a negative b and b is negative 12, so negative 12 would be 12. And then inside your radical here, b squared would be 144. b squared, put a 12 in, 12 squared is 144, and then negative 4ac, if you took negative 4 times 10 times negative 7, negative 4 times 10 times negative 7, you will get a positive 280. And even though this looks like a 9, this is an a right here, so all over 2a, which would be 20. Now if you simplify it inside, you would have 12 plus minus the square root of 424 all over 20. And then if you took with your calculator 12 plus the square root of 424 divided by 20, you would get out 1.6296. Well, I'm not sure what happened there. I was looking at my book while I was reading that to you. So 1.6 296. And then if you took with your calculator 12 minus the square root of 424 divided by 20, you would get out negative, this is not working, I'll write it up here, you would get out negative 0.42, negative 0.4296. All right, now I'm going to pause this and fix this pen. Okay, so we get 0.4296. Now, please watch this, students. Please watch. Let's review. We have a a trig equation in which we tried to factor. We couldn't factor it, so we used the quadratic formula. After you use the quadratic formula, you get out these two numbers. Now, those are not your answers. Let me say that again. Those are not your answers. Please watch what we do with those two numbers. You need to see this, okay? What we do is this. Because we're dealing with sine, we now write this. We say sine of an angle equals 1.6296, and we get that from that number right down here. And then we also say sine of an angle x equals negative 0.4296. So do you see why we used the quadratic formula? We did that so that we would get out these two equations. And now using your calculator, you would write second inverse, or excuse me, second sine or sine inverse of negative 0.4296, and the angle that you would get out would be, let me look at my notes here, would be 25 point, let's see if this is right here. Hold on one second, I apologize. Okay, here we go. If we typed in second sine of negative 0.4296, you would get out 25.44 degrees. I'm just going to call that 25 degrees. So that's the angle we're going to work with. Now notice I want a negative 0.4296, so that means sine is going to be negative here, and sine is negative here. So I'm going to put 25 degrees here and 25 degrees here. So I rotate from here 180 plus 25 more, and that's going to be 180 plus 25 more would be 205 degrees. So there's one answer. And then I would go from here and rotate all the way to hypotenuse. So I did not quite get to 360. I stopped 25 degrees short, so that would be 335 degrees. 335 degrees. Okay, now the reason I wrote my two answers in degrees here is because notice your domain is also in degrees. Now this is pretty easy here. When you take your calculator and type in second sine or sine inverse of 1.6296, you're going to get out no solution or undefined or can't be done or whatever, and that's true. There is no angle whatsoever that when you take the sine of it, you will get out 1.6296. Ever, Mr. Earhart? Ever. That is impossible. So for this part of the equation, there's no solution. So there's your two answers right there. Pretty cool. Pretty cool. All right, number 8. Now we're getting into some tricky problems. Let me grab a drink of water here. Okay, now on number 8, notice we have, for the first time ever in any of our trig equations, we have two trig functions. We have a cosine and a tangent. So what we're going to have to try to do here is we're going to have to try to make, well, actually it equals tangent first of all. So let's always try to get one side equal to 0, because students, sometimes you can factor. Now, not always, but sometimes you can. So let's bring the tangent x over, and when we do, it becomes a negative tangent x. Now this might work, because now I've got one side equal to 0. Here's one term. Notice it has a tangent. Here's another term. Notice it has a tangent. I might be able to factor out a tangent out of both of these terms, and that would be really helpful, because if I do that, then I get rid of this tangent. There'll be no tangent with the cosine. So let's factor out a tangent. Just watch what happens here. Let's factor out a tangent x, and let's see what happens. So pull out a tangent x, and we're left with, let's see, 2 cosine squared x minus 1, because tangent times 2 cosine squared is 2 cosine squared tangent, and tangent times negative 1 is negative tangent. This is really good, because now we take each part and we set each part equal to 0. And look, this part here has a tangent only, so that's good. And this part here, tangent x equals 0, sorry about that. And this part here has a cosine only, so 2 cosine squared x minus 1 equals 0. So we're doing really well. Now here I'm looking for an angle that when I take the tangent of it, I get 0. Over here, I've got to do some work. First of all, I've got to bring the 1 over and make it a positive 1, and then divide by 2. So I get cosine squared x equals 1/2. Now take the square root of both sides, and look what you get, students. The square root of cosine squared is cosine. The square root of 1/2 is plus minus. Now watch this. What's the square root of 1? Well, it's 1. And what's the square root of 2? Well, I don't know, so I put square root of 2. Let's go over this again. I brought the 1 over, I made it positive, then I divided both sides by 2. I noticed I had cosine squared, so I took the square root of both sides. The square root of cosine squared is cosine, and the square root of 1/2 is plus minus. The square root of 1 is 1. I could put a square root here, but the square root of 1 is just 1. And the square root of 2 is square root of 2. Now look what happens next. See if this makes sense. Next I'm going to put cosine x equals plus minus square root of 2 over 2. Because remember, 1 over square root of 2, this number right here, I can multiply the top and the bottom by the square root of 2, and I get square root of 2 over 2. Now, I'm going to show you in a second why I did that, okay? But so here's what we've done. Let's review. I brought the tangent over, made it negative, and then factor out the tangent. And then you take each group and set each group equal to 0, okay? Now I'm going to go ahead and erase. Did not mean to do that. Let's back that up there. There we go. I'm going to go ahead and erase this step. And then erase this information here. So we'll have some room. There we go. Now you're going to see in a second why I made it square root of 2 over 2. All right, let's go ahead and take a look here. When does tangent give you 0? Nowhere on this chart, so we'll have to use a calculator for this. When does cosine give you square root of 2 over 2? Well, right here it is. The cosine of 45 is square root of 2 over 2. And now you see why I made it square root of 2 over 2 and not 1 over square root of 2. Because nowhere on your table is going to be 1 over square root of 2, but on your table there is square root of 2 over 2. So the cosine of 45 is square root of 2 over 2. So I'm going to go ahead and write real small right here, 45 degrees. I'm going to use that in just a second, okay? All right. Now, let's go ahead and do our calculator problem first. Tangent of x equals 0. So, what I'm doing is I'm hitting second tangent or inverse tangent of 0. And if you do that correctly, you will see that you get out 0 for your answer. So, as soon as you get out 0, students, you need to remember, okay, it's an axis angle, 0. So, I'm also going to check 90, 180, and 270. Well, the tangent of 90 is not 0, but the tangent of 180 is 0. So another answer is 180. The tangent of 180 is 0, and the tangent of 270 would not be 0. Okay? So the two answers that would satisfy this equation would be 0 and 180. Now we come over here. Oh, one of these. They're so tough. We got to deal with all four quadrants because we want to know what angle gives me out a positive and a negative square root of 2 over 2. So cosine's positive here and here. Cosine is negative here and here. So I'm going to put 45 degrees in all of my triangles. And I'm going to go around pretty quickly here, okay? All right, if I go from here to here, there's one angle, 45 degrees. Then if I go from here to here, that would be 135 degrees because I did not quite go to 180. And then from here to here, that's 180 plus 45 more. That would be 225. And then from here all the way to here, that would be 315 degrees. So there's your four answers, one for each quadrant for this part of the equation. And men, I hate to do this. Let me get a drink of water here. I hate to do this to you, but you've got to learn your trig, and you've got to learn it well. Remember, this is the first trig equation we've ever done where we had two trig functions up top here like this. To start off in your original problem, we had a cosine and a tangent, remember? Well, whenever that happens, please write this in your notes. Please write this in your notes. Whenever a trig equation has two trig functions at the beginning, you have to always check your answers in the original equation. You have to. So you've got to put a 0 in for here, here, and here, and make sure you get out a true statement. Then you've got to put 180 in for here, here, and here, and make sure you get out a true statement. You have to check each one of these answers. Now, you only have to do that when you have more than one trig function in the original problem, okay? Now, in this case, if you check each one, all of them do work, so we're okay. But the only problem, excuse me for yawning, I apologize, the only problem with these answers is notice your domain is in radians, so you do want all of this to be in radians. So here's your final answer, 0, and then 180 is pi, and then 45 degrees is pi over 4, and then the other one would be 3 pi over 4, and then 225 would be 5 pi over 4, and then 315 degrees would be 1 3/4, 4 would be 7 pi over 4. On some of these problems, unfortunately, you might have to back up the video and watch it a couple times. I told you no homework, so just a long video, but that is how you would solve this. It's not easy. These are pretty tough, okay? All right, let's take a look at number 9. Now, number 9 is going to blow you out of the water, so please pay close attention. The problem with number 9 is we have a sine and a cosine, two different trig functions. Now, in the last problem, when we had two trig functions, we were able to bring the tangent over and then factor. You can't do that with this. There's nothing you can pull out that's common. So sometimes you have to manipulate things. Sometimes you have to increase size, make substitutions, all kinds of crazy stuff to make this work. So here's what I'm going to do, and in the end you'll see why I did this. I'm going to take the left side of the equation and I'm going to raise it to the second power. You can't do that. Well, sure I can, as long as I take the right side and I raise it to the second power. Now if I do that correctly, 1 squared is 1. Now over here, trust me, if I took sine x plus cosine x squared, that means I have sine x plus cosine x times sine x plus cosine x. That means sine times sine, sine times cosine, cosine times sine, cosine times cosine. It's going to be a lot of work. Okay, I'm going to save you time on that. If you do all that correctly, you'll get this. You will get sine squared x plus 2 sine x cosine x plus cosine squared x. Okay, if you do all that correctly. Now look what I can do next, please, students. See my term here, 2 sine x cosine x. I'm going to write that first. 2 sine x cosine x. And then I'm going to write my sine squared next. So positive sine squared x, and then my cosine squared x would be next. Now here's why I did that. Watch. I squared all of this so I would get a cosine, a sine squared plus a cosine squared. And if you look at your Pythagorean identities, sine squared plus cosine squared, all of this right here just equals 1, positive 1. And now bring that 1 over and make it a negative 1. So now you're left with 2 sine x cosine x equals 0. That's hard, and I think very quickly I should go over this again. I noticed in the very original problem I have a sine and a cosine. So I squared both sides hoping to get something that would help me. When I did, I came up with this. So I took my sine squared and I wrote it right here. So I had sine squared plus cosine squared, and that equals 1, so I put a 1 here. Now bring the 1 over and make it negative. So now I'm left with 2 sine x cosine x equals 0. That's still just really not a lot of help, okay? Unless you remember this. If you'll look at your trig identities, look at your double angle identities, and you will see in your double angle identities that sine of 2x equals 2 sine x cosine x. And that's what you have right here is 2 sine x cosine x. So what I can put, I can substitute for 2 sine x cosine x, I can substitute sine of 2x equals 0. Sine of 2x equals 0. Now you might have to go back and watch this a couple times. I'm not sure. Whatever you feel like you need. But I just took this entire thing and I did a bunch of simplifying and I broke it down to this right here. So this whole equation here now became this right here. So I'm looking for an angle that when I take the sine of it, I get 0. Now, if you look on your table, nowhere do you see a 0 for your sines. So what I'm going to have to do is use my calculator. So if I hit second sine equals 0, what I'm going to get out is 0 degrees. And so right away I realize I have an axis angle. So I've got to try 0, 90, 180, and 270. So you try all those angles and here's what you come up with. The sine of 0 is 0, but also the sine of 180 is also 0. So the angles we're going to be dealing with here are 0, 180. Now think about before. Think back way back here to problem number, right here, number 4. Remember when I had tangent of 2x equals negative 1? I didn't really care what 2x was. I wanted to know what x was. So when this whole angle was 135 degrees, the tangent of 135 is negative 1. I then said 2x equals 135, and I divided by 2 because I wanted to see what x is. We're going to have to use that same principle here. The whole entire angle is 0. The sine of 0 is 0, but I want to know what just x is. So I take 2x, set equal to 0, divide by 2, and x equals 0. Now, the next angle I told you that we had was 180, remember? So if I take the sine of 180 degrees, I get 0. But I don't want to know what the whole angle is. I want to know what just x is. So I take 2x, and I set it equal to 180. I divide both sides by 2, and x equals 90. But remember, students, I want to go all the way up to 2 pi, or 360 degrees. So now I take my 0. Remember, one angle was 0. I'm going to erase this a little bit here. Remember, one angle was 0. Remember earlier I said the sine of 0 is 0. Well, now I'm going to add 360 to that because you're always allowed to add 360, and 0 plus 360 is 360. So now, if I take the sine of 360, I will get 0. But I don't care what that whole angle is. I just want to know what x is. So I'm going to take 2x, set it equal to 360, divide both sides by 2, and x equals 180. All right, now let's continue on. I'm going to add 360 to 180 because one of my angles was 180. Well, 360 plus 180 is going to be 540 degrees. So I'm going to go ahead and write 540 here. So basically what I'm saying is if I take the sine of 540, I will get 0, and that's true. But I don't want to know what the whole angle is. I want to know what x is. So I'm going to say 2x equals 540 degrees. Divide both sides by 2, and x equals 270 degrees. Okay? Now all of this is fine, but there's something unfortunately you need to know. Remember in the last problem I told you whenever an original problem has more than one trig identity or trig function, excuse me, like a cosine, a sine, you've got to take your answers, you've got to check them. Well, there's something else you need to know. Anytime you take an equation and you raise it to a certain power, sometimes you get what we call extraneous solutions. And did we not earlier in this problem raise this to the second power? Sure we did. So some of these answers might not work. So in this situation also, when you raise one side of the equation to a certain power, you're going to have to check your answers. So we have to take each one of these and put them in for x and see if we get a true statement. For example, 0. Sine of 0 plus cosine of 0 equals 1. And you've got to type that in your calculator and see what you get out. Well, if you do all of that correctly, you're going to see that the only two that work are 0 and 90 right here. 0 works, 90 doesn't. If you put 180 in, let's say I'm trying to think what you would get. The sine of 180, if you put 180 right here, the sine of 180 gives you 0, and the cosine of 180 gives you -1, and 0 plus -1 gives you -1, and you want a 1 right here. So 180 would not work, and neither would 270. If you take the sine of 270, you will get -1 plus, and if you take the cosine of 270, you'll get 0. So -1 plus 0 is -1, and you really want to get out 1 over here. So these two answers here, when you check them in the original equation, they don't work. So here's your two answers, but you must write them as radians because of your domain. So one answer is 0 radians, and the other one is pi over 2 radians. Okay, so there we go. 9 down and just 2 more to go. So we're really doing well, and we're almost finished. Let's take a look at number 10. Now, when I first glance at number 10, I notice right off the bat that I have a cosine and a sine in my original problem. Let's go back 2 problems to number 8. In the original problem here, I had a cosine and a tangent. So I tried to bring the tangent over and factor, and when I factored, it worked. Everything fell into place, and that's one thing you can do. In number 9, I had a sine and a cosine. Factoring would not help, so I decided to take this side and raise it to the second power, and take this side here and raise it to the second power. And that worked. But now look at number 10. None of those things are going to help me. I cannot factor this, and raising it to the second power with an angle of x and an angle of 2x is just really not going to work. So I'm looking for a substitution to make. Well, I notice in my double angle identities that the cosine of 2x equals 1 minus 2 sine squared x. 1 minus 2 sine squared x. So I take this and I substitute it out for this right here, then bring down your plus sine x equals 1. Now notice your 1's are going to cancel off on each side, or if you don't like to say that, bring the 1 over and make it a -1, and you get a 0. Either way, the 1's are going to cancel out because you have a positive 1 on both sides. So what we have now is simply this: -2 sine squared x plus sine x equals 0. And now look, how many sines do I have here? 2 sine squared. How many sines here? 1. I can factor out a sine, and we're home free. Factor out a sine, and I'm left with -2 sine x plus 1. So what did I want you to learn from this problem? Well, when the original problem has 2 different functions, sometimes you'll have to factor like we did here. Sometimes you'll have to raise both sides to a power like we did here with number 9. But sometimes, like number 10, you simply make a substitution, and then you have all signs all the way through the problem. Okay, so we have my one group here is sine x, so I'm going to write sine x equals 0, and then I'm going to write -2 sine x plus 1 equals 0. Well, here Sorry about that, my pen's messing up. Now here, if I want to get sine x by itself, I bring the 1 over and I make it a -1. And after I do that, I divide by -2. So I would end up with sine x equals a -1 over a -2, which is a positive 1/2. Positive 1/2. So I've taken this whole entire equation and I've broken it all the way down to these bottom two equations. So let me very quickly do some erasing here. Okay, very good. And there. So I've done all of my work. I've got everything broken down into this right here. So now I have two equations to very quickly solve. Now, on my table, I see nowhere where sine gives me out a 0. However, I do see where sine gives me out 1/2 right here. The sine of 30 is 1/2. So I know right here I'm dealing with 30 degrees. So I'm going to go ahead and draw my coordinate plane. I want a positive 1/2, so that's here for sine and here for sine. We'll put a 30 here and a 30 here. All right. So we rotate up. One answer would be 30 degrees. And then I go from here to here. And the next answer would be 150 degrees. We didn't get all the way to 180. Now, over here, if you'll look at your table, nowhere is there sine of an angle that gives me 0. So we're going to have to use our calculators. If you type in second sine or inverse sine of 0, what you will come up with is 0. So right away, as soon as you see that 0 is one of your answers, you realize, oh, that's an axis angle. So I've got to try 0, 90, 180, and 270. Well, the cosine of 0 is 0. So there's one. I mean, the sine of 0 is 0. So there's one answer. The sine of 90 does not give you 0. The sine of 270 does not give you 0. But the sine of 180 does give you 0. So another answer to this part of the trig equation is 180. Okay, 180. So it looks like to me I have four answers. I have 1, 2, 3, 4. But hold it. Remember what I taught you way back at the beginning. Whenever the original problem has two different trig functions like cosine and sine, you have to take each individual answer and plug in each individual answer and see which one of those works. Okay, make sure they all work. And so if you do that correctly, if you take 0 and take cosine of 2 times 0 plus sine of 0, you'll get 1. If you check each one of these in the original equation right here, all of them will work. Every single one of them will work. So we're good. So, but look at your domain. Your domain is in radians, so we got to write our answers in radians. So we have 0 radians. We have pi for 180 degrees. For 30, we have pi over 6. And for 150, we would have 5 pi over 6. Okay, so there's your four answers that satisfy this trig equation. These are really, really hard, and I hope you guys are getting this. Well, last one, and we're finally done. So hang in there. Last one, and we're finally done. Now notice I have a tangent and a secant, and that's really not going to work. Factoring is not going to help. Probably squaring both sides with 3 terms over here is not a good idea. However, I do know of a substitution I can put for tangent squared, and when I do, I will have secant. And the substitution is, look at your Pythagorean identities, and you'll see secant squared x minus 1, and then bring down the rest here, plus secant x minus 1 equals 0. Let's go ahead and simplify this left side. We know we have secant squared, and then next would come secant. Then -1 is -2 equals 0. Well, I can probably factor this. I have a secant squared and a secant. This is one of the easy ones. I have a lead coefficient of 1 right here. So really, I just have x squared plus x minus 2. So what two numbers when multiplied together would give me -2? When added together would give me a positive 1. Well, that's obviously going to be a positive 2. Let me get a drink of water real quick. That's obviously going to be a positive 2 and a -1, because when you multiply them, you get a -2. When you add them, you get a positive 1. So the factorization would be x plus 2, x minus 1. So how I write it over here would be secant x plus 2. And then, of course, secant x minus 1. All of those equal 0. Now, so what I did is I made a substitution. I made a substitution for tangent squared, and then I saw that I could factor it. And that's all I really need to worry about, okay? So let me go ahead and very quickly slide this out of the way. Actually, I'm going to go ahead and go a step further and do some more work with this. So now that I've factored, I can take this group here, secant x plus 2, so that equal to 0. And then I would have secant x equals a negative 2. Then over here, secant x minus 1 equals 0. Bring the 1 over and make it positive, so secant x equals 1. Okay? So there we go. I've taken each group and set each group equal to 0. And there we go. All right, so let's go ahead and take a look. Now, we might have stuff on our table. Let's see. Yeah, it looks like we do, at least for part of this. Look, secant, right here, if you'll look carefully, please. Secant of 60 gives me 2. Secant of 60 gives me 2. So I know right here I'm dealing with 60 degrees. And I'm dealing with the negative secant. Of course, secant is the inverse of cosine, and cosine is negative here, and cosine is negative here. So I'm going to put, did I say 60? Let's see. Secant of 60 is 2, yes. So I'm going to put a 60 right here, and a 60 here. So I rotate from here to here, so 120 degrees. Then I rotate from here 180 plus 60 more, and that's going to be 240 degrees. So there's a couple of answers. Now let's come over here to my secant. My secant of an angle gives me 1. Secant of an angle gives me 1. Now, using a you can't use a calculator because there is no inverse secant button. So what you're going to have to do is, I call it flipping both sides. You're going to have to flip the left side, and when you flip secant, you really get the inverse, or the inverse. So when you flip secant, you really get cosine. And over here, when you flip 1, 1 is really over 1. So when you flip 1 over 1, you get 1. So when does cosine give me 1? Well, if you'll type into your calculator second cosine of 1, you will get out 0. So right away, as soon as you get 0, you say to yourself, okay, I had better check other quadrant angles. So 0, 90, 180, and 270. Well, cosine of 0 is 1. Cosine of 90 is not 1. Cosine of 180 is not 1. And cosine of 270 is not 1. So the only angle that we can use for x right here is 0. So there's your 3 answers right there. Right there. Put that right there and put a comma. Now you look at your domain and you realize your domain is in degrees, so you know you have to be in degrees, and that's fine. But then one other thing we almost forgot to do is, whenever your original trig equation has more than one trig function, like a tangent and secant, you must take 120, put it in for all the x's, check it, make sure you get out a 0, then put 240 in for x, check it, and make sure you get out a true statement, and then put 0 in for x everywhere, check it, and make sure you get out a 0. If you do that correctly, you will see that all 3 of these do work, so you're okay. All right. Now, you do not have to do your homework. There is no homework. But if you're really feeling diligent and you want to get a head start, this is the homework we're going to do tomorrow. Okay, the video's not made yet, but this is the homework we're going to do tomorrow. So if you want to get a head start on it, feel free to. If you don't, that's totally fine, because we're not going to work on it really until Thursday, okay? So I hope that this has helped. I know it's been difficult. I understand that. The good news is we're so close to being done with trig, one more chapter, and then we'll start getting into the real other pre-calculus stuff, okay? So you've done really well. We've covered almost 2 chapters and one more chapter to go of trigonometry, and we'll be done. If you have any questions, don't hesitate to email me or call me, and please stay on top of your integrity sheets, and hope you have a good rest of the day.